Okay, discrete mathematics. So the last two sections of chapter 1 are going to be about mathematical proof. Proof is something that mathematics is really founded on, the idea of proving something is true based on other assumptions or previously proven facts. All of mathematics is built up around this idea. So, first of all, what is a proof? A proof is a valid argument that establishes the truth of a statement. So we learned in section 1.6 what an argument is. It has several premises, and if you assume all the premises, then you can guarantee the truth of the conclusion. So that's what an argument is. And so a proof in mathematics is something that we use to sort of establish truth, right? Well, what is truth? Let's talk a little bit about that, because in other realms other than mathematics, the idea of truth is a little bit hazy. So, for example, what you sense with your eyes and ears, if you see it, then it's true. If you hear it, then it's true. That is, a little bit arguable. There's some evidence that what our senses do, what our senses tell us, what we perceive, is more attuned to what's going to best serve us rather than what's actually true. So we may have evolved not to sense reality as it is, but rather to sense reality as as is most convenient for us to sense it in order to survive and reproduce, and so on and so on. Senses might give us truth, or they might not. In science, truth is sort of established around this idea of evidence, right? If you gather a lot of evidence, then you can have a pretty reasonable expectation that something is true. Like the sun rises every morning, so it's probably going to rise tomorrow too, right? But notice that I said probably. In science, there's a lot of, the evidence suggests that this is most likely to be the case, so we're going to act under the assumption that this is the truth. But you never really prove anything by gathering a bunch of evidence, right? You can never really prove that the sun is going to rise again tomorrow, because it rose every day for the past, several billion years. Anyway, in mathematics, things are a little different. In mathematics, we like to think that we can really prove things beyond a doubt. However, they are based on some assumptions. So let's talk about the assumptions that everything is based on. We have in mathematics these things called axioms. And I'm just going to sort of draw a picture to sort of explain what math looks like. The axioms are like the foundation of the building. And that is mathematics. So let's say that these blocks here represent the axioms. I'm just going to label them with A. All right. So then these things are statements that we consider to be so foundational, so simple, that they are obviously true. And we're going to take them on faith, in a sense. We're going to say, these are the axioms of our mathematical system. In modern mathematics, the set of axioms that we consider to be the foundation of everything is something called the Zermelo-Fraenkel set axioms. Sometimes with the addition of something called an axiom of choice, which is a little bit controversial, and some of you may get to study that in your project this semester in more detail. Very interesting subject, the axiom of choice. Anyway, the Zermelo-Fraenkel axioms with possibly plus choice are sometimes abbreviated as ZFC. And we might get a chance to talk about those a little more at a future time when we get to set theory in chapter 2. But so those are like our axioms. And then other truths that we discover in mathematics are sort of like blocks that rest on top of those axioms. And their truth is dependent upon the truth of the axioms beneath it. So if you have a block here that rests on top of two axioms, the proof of one of these truths, one of these blocks might represent a statement. In mathematics, it's called a theorem. And the proof of that may use as its premises the axioms that it is based on, right? And then the proof is an argument using those as premises and using this as a conclusion. And then its validity can be shown, and to establish the truth of that thing. So that's kind of what math is. It's just this huge, very complicated stack of blocks. I'm the father of a 3-year-old, so I do a lot of block stacking and Lego construction. So this is a really good analogy for me. So let's just introduce a little bit of vocabulary here. Like I was saying, any of these blocks, any truth that you encounter, that you're able to prove in mathematics, that's called a theorem. So we are going to be looking at a lot of theorems in this class. And there's a few other types of theorems that have special names. So all the things I'm going to explain here are different types of theorems. Sometimes you have a theorem that exists mainly just to support a more important theorem, like a little theorem that just exists as a sort of a table leg that holds up a bigger, more important theorem. Those little ones are called lemmas. So here in this picture, let's say these two little ones here are lemmas. They just exist to support this bigger one. And they might not do very much else, but maybe they do. Maybe there's another theorem over here that can, be proved using that lemma as well. Anyway, lemmas are like little theorems that we use. And then sometimes after proving a theorem, there can be like another theorem that follows pretty much immediately, that like only requires this one theorem as its premise. Like if this theorem is true, then the next theorem is guaranteed to be true. And it doesn't require really anything else, like it's immediately following. That is called a corollary. So you have a theorem which may be followed up by one or more corollaries like immediately after it. And then all of this is kind of a picture of what math is, all right? So you may, have gone through school thinking, well, math is the study of numbers and stuff, right? Numbers and then functions and then like calculus and rates of change and all this. Okay, yeah, that stuff is all within mathematics, but that's not really what math is. Math is really a system of logic, like this structure that is really established with logic, that is about lots of different things, not just numbers, but sets. It's about algorithms. It's about machines. It's about diagrams and pictures and surfaces and spaces and properties of the universe. Like, it's about a lot of things, and it's all tied together through this idea of logic and proof. So, in section 1.7, we're going to move on to introduce some different basic proof strategies, and you're going to start practicing writing your own proofs, because as you move up in the world of mathematics and take more higher level math classes, you're going to be expected to know how to write proofs. Okay, so this is going to introduce you to some of the basic concepts and some of the basic strategies. So here we go.